All right, we are going to be doing simplifying rational expressions. This is going to be a short section before we get into statistics after a break. So anyway, rational expressions, rationals are simply fractions. So I have two fractions written here, and they look fairly complicated. What we want to do is we want to get them into the simplest terms possible. And basically, what we need to do is factor first and then cancel. And that's what pretty much all of this is going to boil down to, is factoring and canceling. But it's been a while since we factored, so I'll spend a little bit of time reminding us of that. So let's take a look at the first one. So I'm going to factor the numerator first. And the first step of factoring is take a look at all our terms and is anything in common between all three terms. We might think x, but this last term does not have an x. So that's not going to work. So since it is a trinomial, I'm going to factor it into binomials. And to get the first term, generally that's the easiest. I have an x, and an x squared. The way to get that is to do an x times an x. Because if I multiply these two, x times x gives me x squared. And now I need to think of my factors of 24. And specifically, the factors of 24, which will give me a 5 somehow. So I take a clue from this sign. This is a negative 24, which tells me that I'm going to be subtracting the factors in order to get the 5. And I'm thinking 3 and 8. Because 3 times 8 gives me 24. But if I subtract 3 and 8, I will get a negative 5. Well, I want a negative 5. So I'm going to do 3 and 8. And I want a negative 5, so minus 8 and plus 3. And I do a quick check. 3x minus 8x does give me a negative 5. So that's good. Right here, again, denominator, I don't have a middle term, which means it's a 0. So I want factors of 64 that will combine to give me a 0. And since this is a minus 64, I know I'm subtracting them. And I'm thinking 8 and 8, because 8 minus 8 is 0. So I'm going to do x plus 8 and x minus 8. And now I'm done factoring. I'm ready to go on to the next step. So I did that. Now I'm going to cancel. What can I cancel? So I look at numerator and denominator, see what do they have the same. Oh, look. They have these the same. So I can cancel both of those. And that leaves me with my answer, x plus 3 over x plus 8. And I want to think, before I go on, I want to think, is there anything that x simply cannot be? And the denominator can't equal 0. So that means x cannot be negative 8, because if x were negative 8, then my denominator would be 0. All right, so let's take a look at this second one. The numerator, we can't assume that we always factor, like if possible we factor. There's nothing that I could possibly factor there. But to help me out in identifying the groups, I'm going to make sure it's in parentheses to emphasize this is a whole group up here. Now I take a look at my denominator, and I'm actually going to show our steps over here. I see that something is in common. A 3 is in common, so I'm going to factor out the 3. And now, this one's pretty tricky. I'm going to copy that 3 down. And this one actually works like this x squared minus 64. How do I get a c squared? That's going to be c times c. And how do I get a d squared? That's d in d. But in order to get nothing in the middle, one's plus and one's minus. So I'm going to copy that down. And I take a look, what's in common? Well, c plus d is in common between numerator and denominator. So those cancel. When they cancel, they don't change to zeros, though. They change to a 1. So I have 1 over 3 times c minus d. And this is my answer. And this was my answer over here. Now remember, that canceled to 1. I want to show you something. Do not write this down or anything. Just kind of follow along here. This is a common mistake. Oh, cancel the C? Oh, cancel a D. You cannot do that. You can never, you can never cancel through anything but one thing, multiplication. See, I switched all of this to multiplication, which allowed me to cancel. I can never cancel through addition or subtraction or division. Only multiplication will canceling work. So if you had something like this, if you had A plus B all over AD, you cannot cancel the A's. Why? Because I just canceled through this addition symbol. That's not allowed. All right, let's try another example, but now we're going to throw something else into the mix. So notice here, it's not just one fraction, it's two fractions, and I am multiplying those two fractions. But the steps are the same. I'm going to factor, and I'm going to cancel, but I'm also going to multiply as I'm doing it. So I look at this first fraction, and the numerator specifically, nothing in common. So I start my factoring, x times x, and 16. Factors of 16, now this is a minus, so factors of 16 that when I subtract them, I get a 6. And I'm thinking 2 and 8. Because if I do 2 minus 8, I get negative 6. So 2 and 8. The 8's going to have to be negative, and the 2 must be positive. The order of these, where we put our plus and minus, does matter. The 8 has to be negative, because when I do 2 minus 8, that'll give me a negative 6. If I did 8 minus 2, that gives me a positive 6, which is not what I'm looking for. All right, let's factor the denominator. And I'm not going to explain every factoring. That would take forever. So that's the factoring for the denominator of that fraction. This numerator does not factor, but I will throw it in parentheses. And the factoring of this fraction right here, the denominator, is x plus 2 and x plus 3. Give you a second to digest that while I switch up the colors a little bit. Let's see what cancels. So I see a lot of canceling could go on. I always cancel crossways or up and down, never sideways. I wouldn't do this. All right, we cross cancel like up and down. So there's a lot of things going on here. X minus 8 will cancel with x minus 8. X plus 2 with this x plus 2. And this x minus 8 with this x minus 8. And these are all changing to 1s, not 0s. So now I'm ready to do top times top, 1. Bottom times bottom, I'm left with x plus 3. And I'm done. And again, I'm going to think, what can't x be? X cannot be negative 3. Because if x were negative 3, then I'd have a denominator of 0, and that's not going to be allowed. All right, this one's going to have another step, division. So let's think of fractions here for a second. If I had 3/4 and I was dividing by 1/2, I'm going to do the shortcut, explain it a little bit why the shortcut works. I keep the first fraction. I flip the second one. And the shorthand answer for why I flip that is because division is the inverse opposite of multiplication. So if I switch to multiplication, I'm going to flip this because I'm doing the opposite of that. Cross cancel. And now I would have 3 over 2. So what's my extra step? I'm going to factor, but I'm also going to have to flip this second fraction. So this fraction is a difference of perfect squares. So we're going to get x minus 4, x plus 4. Now this one has a y. I'm going to have to be careful here. And I look at the 12 and 36. 36 happens to be divisible by 12, which means I could factor out a 12. So I'm going to. So I have y plus 3. I divided both of those by 12. This is division, so I'm going to switch to multiplication. So when I factor, I'm going to put these factors down here. And I'm going to put these factors on top. So let's do the numerator here, but it's going to end up in the denominator. X and x gives me x squared, and factors of 32 that give me 12. I should think 8 and 4. both minus, because this is a plus, so I know I'm adding my factors, and 8 plus 4 is indeed 12, but it's a negative 12, so those both have to be negative. And if I check, negative 8 times negative 4 is positive 32. Now I'm going to factor this denominator, but it's going to end up in the numerator. And notice it's y, so we're being kind of tricky here. It's not an x, it's a y. This is a minus 18, so that means I'm subtracting my factors. And factors of 18 who have a difference of 3, right here, are 6 and 3. So the 6 is going to have to be the negative one, and the 3 is going to have to be the positive one. Now let's see what cross cancels. Got to be careful. It looks like I have an x minus 4 and an x minus 4 cross cancel. Looks like I have a y plus 3 and a y plus 3 cross cancel. And then that looks like it's it. So I have, as my final answer for this, looks like I have in my numerator x plus 4, y minus 6, all over 12, x minus 8. And I want to note x cannot be, well, let's think for a minute. What would make this denominator 0? 8. X cannot be 8. Sometimes these are already factored for you, in which case, don't argue with it. Oh gosh, look at this. It's nasty. It's a fraction within a fraction and a fraction. So before we do that, let's see. What if I had a half over 3/4, like this? A fraction bar means to divide. So I'm actually dividing. So I'll rewrite it as division. A half divided by 3/4. Keep, flip, change, KFC. Cross cancel, and top times top, bottom times bottom, 2/3. So let's see if we can work that here. So I am going to have to factor. The x squared does not factor. This does factor. These are difference of perfect squares. 3x, 3x, 3 times 3 is 9, x times x is x squared. 4, thinking 2y, 2y, one of them plus, one of them minus, because I have a 0 in the middle. Going to be multiplying now. Why I'm multiplying? Because I'm going to keep flip change, right? So I'm actually flipping this fraction around. So I have an x cubed on bottom and a 2y minus 3x on top. Now let's see some things that are going on here. Doesn't this one look almost like these, just in a different order? Like, what if this 3 were positive? So I can pull a trick right here so that I can get it to cancel. And I'm actually going to switch it to negative. I'm going to factor out a negative and make it negative 2y plus 3x. I factored out a negative, which changes the signs. So now that's going to be able to cancel. And it's going to be able to cancel specifically with this one. But I have a negative in front now. Now, I have an x squared here and an x cubed here. So two of these x's will cancel with this x cubed, leaving me just an x. And then I have the 3x plus y. So I'm going to get for my final answer, top times top, but remember I canceled all this, and this is a 1, and 1 times, well, what did I have here? I factored out a negative, so negative 1. I have this x, and then I have this group left right here, 3x plus 2y. Now, we can't say too much about what y can't be, but we can say definitely that x cannot be 0. Because if x were 0 here, then this whole thing's 0. So this is our answer. All right, there's a lot of these. This one is actually simpler than the previous one, but because it's just like sometimes the easier ones are just harder. This is division, so I'm going to keep flip change again. And I'm going to do that all in one step, so I keep my top fraction. I'm changing to multiplication, and this bottom one I'm going to flip around. x squared y, a squared b. And now I'm going to take a look for what cancels. And it looks like, looking crossways, I have a squared here and a cubed here. So both these a's go away, leaving me the single a right here. I have b cubed and b, so this b cancels with this. That leaves b squared. X and x squared leaves me with x. And I have y to the fourth and y, so 3 of those y's are left. It gets really sloppy. I think that might be the thing. So I have, what do I have left? I have a b squared x. That is written in the right order, alphabetical order. And looks like y cubed. And y cannot be 0. Can't have a 0 in the denominator. Yeah, that's almost harder in a sense. It's simpler, but harder. Let's go back to multiplication for a second. So, what are our steps? Let's emphasize these steps. Factor, cancel. So, how can I factor this? X minus 7, x plus 3. Factor our denominator. No flipping. I'm going to put that in group. That second numerator does not factor. Factors of 35 whose difference is 2. Thinking 7 and 5. 7 times 5 is 35. Now what cancels? What crossways are x minus 4s? Or x minus 7s? That's it. So top times top. Remember, these are changing to 1s, not 0s. X plus 3. Now at bottom, I have x minus 2, x plus 5. In other Regents exam, they actually might multiply that out. There's no way to know what they're going to do. But we might want to know x cannot be. Well, what would make this 0? This cannot be 0 down here. Numerator can be 0, not denominator. X can't be 2. If this is a 2, then that's 0. What can't x be right here? X cannot be negative 5. Negative 5 plus 5 is 0. So, there's our answer. All right, last one. Then you get lots of work to do all by yourself. Right here, big fraction. Keep the top. Nothing factors. Keep the bottom there. Nothing factors. Now, what do I have to do here? I'm dividing, so I switch to multiplication, which means this has to flip around, right? Let's talk about this x squared minus 3x first. I'm going to factor that, right? There's nothing here. Nothing. But something's in common here. What can I factor out? X. I don't know why. It's like every time, Algebra 2 students, they get to this and they forget that they can factor out that x. So x times x is x squared. Now how many x's are left over here? Just none. They're gone. So at top, well, not at top. I have to flip, right? Keep flip change. So I'm flipping this. So x minus 3 is on bottom. This other fraction, that's going to be, or this one's going to be easy. Plus 6, we had something like it already. All right, what cross cancels? Throw that in the group. All right, we have x plus 6's cancel. X minus 3's cancel. X's cancel. I'm left with a 4. Everything else went away, so 4. That's it. And what can x be? There are no x's, so it don't matter.